How do birds fly? Birds are able to fly due to their unique anatomical and physiological adaptations. Here's a simplified explanation of the key factors that enable birds to take flight. Wings. Birds have wings, which are specialized appendages designed for flight. The shape and structure of their wings allow for the generation of lift. The primary feathers at the end of the wings provide most of the lift and control during flight. Feathers. Feathers play a crucial role in flight. They are lightweight yet strong, and their arrangement helps to streamline the bird's body, reducing air resistance. Feathers are also used for insulation, display, and communication purposes. Hollow bones. Bird bones are hollow and lightweight, which reduces their overall weight while maintaining strength. This adaptation helps birds achieve a more favorable strength-to-weight ratio, making flight easier. Muscular system. Birds possess strong flight muscles, especially the pectoral muscles located in their breast area. These muscles are responsible for the flapping motion of the wings, generating the necessary lift and thrust. Respiratory system. Birds have a unique respiratory system that allows for efficient oxygen exchange. They have air sacs connected to their lungs, which enable a continuous flow of fresh air and a high oxygen supply during flight. This system enhances their endurance and performance. Flight technique. Birds use a combination of flapping, gliding, and soaring to achieve and maintain flight. Flapping their wings generates lift and propulsion, while gliding and soaring allow them to conserve energy by utilizing air currents and thermals. It's important to note that this is a simplified explanation, and the mechanics of bird flight can be quite complex. Additionally, different bird species have specific adaptations and flight styles that suit their ecological niche and lifestyle. User Practiclet. I can provide a more detailed explanation of the scientific principles involved in bird flight. Lift. Lift is the upward force that counteracts the force of gravity and keeps a bird airborne. The shape of a bird's wing is crucial for generating lift. The curved upper surface and flatter lower surface of the wing create different air pressures. As a bird flaps its wings, the air flows faster over the curved upper surface, creating lower pressure. This pressure difference produces lift. Thrust. Thrust is the forward force that propels a bird through the air. The primary source of thrust in bird flight is the flapping motion of their wings. As a bird flaps, it pushes air downward and backward. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. So, as the bird pushes air downward and backward, the air pushes it forward, generating thrust. Drag. Drag is the resistance encountered by a bird as it moves through the air. There are two main types of drag: parasite drag and induced drag. Parasite drag is caused by air friction against the bird's body and feathers. To minimize parasite drag, birds have streamlined bodies and feathers that align in the direction of airflow. Induced drag is produced as a result of lift generation. When a bird generates lift, it also creates an equal amount of induced drag. Birds reduce induced drag by adjusting the shape of their wings during flight. Wing beat. The wing beat of a bird involves a complex interplay of muscles and tendons. When a bird flaps its wings downward, the leading edge of the wing rotates forward, while the trailing edge rotates backward. This creates an upward and backward stroke, allowing the bird to generate lift and thrust. As the wings move upward during the recovery stroke, they minimize drag and prepare for the next downward stroke. Energy efficiency. Birds employ various flight techniques to optimize their energy expenditure. They alternate between flapping, gliding, and soaring. Flapping provides the necessary lift and thrust, while gliding and soaring allow birds to conserve energy by utilizing air currents and thermals for sustained flight without continuous wing beats. These scientific principles, along with the anatomical and physiological adaptations of birds, enable them to fly. The intricate coordination of these factors allows birds to maneuver, soar for long distances, and navigate diverse environments. Scientists study bird flight using techniques such as aerodynamics, biomechanics, and physiological analysis to gain a deeper understanding of the complex mechanisms involved.